Hi, 6th grade. Today we are going to be starting our reading for our notes on states of matter. This video is just making it through solids. So we're starting on page 301. Let's go ahead and take a look at what we are going to be reading about. So it says, how do you describe a salad? So I'm going to think back to yesterday. I did a lot of describing of salads. Think back to some of the things that I learned. We're going to take a look at the particles in the salad. And then there are actually two types of salads, and I see crystalline, and I see how to say that, crystalline, and then amorphous salads. And it looks like we have a Venn diagram there that we can kind of think about. So here, this is all that we're going to be reading on salads, page 301 and 302. So let's go ahead and get our notes ready to go. Okay, so we are in a new unit. So states of matter. Today's date, and the first state of matter that we're talking about are solids. Okay, so let's take a look at what it means to be a solid. Look at the bowl in figure 1. It contains the metal bismuth. Notice that the shape and size of the piece of bismuth are different from the bowl's shape and size. What would happen if you took the bismuth out of the bowl and placed it on a tabletop? You should be able to stop and think about that. You did things like that yesterday. Would it become flatter? What would happen if you put it in a larger bowl? Would it become larger? Of course not, because it's a solid. A solid has a definite shape and definite volume. Your pencil is another example of a solid. If your pencil has a cylindrical shape and a volume of 6 cubic centimeters, it will keep this shape and volume in any position in any container. So I'm going to go ahead and stop that paragraph right there, and I see the important line here. It has a definite shape and a definite volume. So let's go ahead and add that to our notes. So just to talk about this a little bit, definite shape, we know that it's not going to change its form. Volume, we want to think about, what does volume mean? Well, it's the amount of space that the solid is taking up. So in order to have that definite volume, it means that when we take it out of the container, the space or the size of it isn't changing. Okay, now if we look, let's talk about the particles in a solid. The particles that make up a solid are packed very closely together. Also, each particle is tightly fixed in one position. This fixed, closely packed arrangement of particles in a solid causes it to have a definite shape and volume. Do the particles that make up a solid move at all? Yes, but not much. The particles in a solid are closely locked in position and can only vibrate in place. This means that the particles move back and forth slightly, like a group of people running in place. Okay, so I see a big key here. This fixed, closely packed arrangement of particles in a solid causes it to have a definite shape and volume. So we have a definite shape and volume going on here. They're restating that again, so it's good that we have that in our notes. What we want to describe are the particles. So they're packed very closely together, and they vibrate in place. And that should make sense why it has a definite shape, why it doesn't change shape when we take it out of the container. It's because those particles are pretty much standing in one little area. They can't move other than just to vibrate. So it makes sense why, since the particles can't move, the shape of the object won't change. This is bothering me. I'm going to change this to here. There we go. Just capitalize these first words. Good. Okay. So if we look here, they're actually showing you a picture of what the particles in a solid look like. Now, I also want to show you another resource that I have. Here we go. So the atoms of a solid are strongly attracted to each other, and solids keep their shape because of the strong attractions. The atoms vibrate but do not move past each other. So what you can see, this is really cool. So we have a big anvil here. And we know that this is a solid, so when we zoom in, we can actually see how the particles, they're not moving in any direction, but they're just kind of vibrating. And if we continue looking at this, okay, so if we continue looking at this, you're just going to see that they're not going to move. We'll take a look at comparing the solid and a liquid in the next section on liquids. So let's head back to our video, or head back to our notes. And on our next page, we're going to talk about two different types of solids. In many solids, the particles form a regular repeating pattern. These patterns create crystals. Solids that are made up of crystals are called crystalline solids. Salt, sugar, and snow are examples of crystalline solids. The fluorite crystal, shown in Figure 2, is an example of a colorful crystalline solid. When a crystalline solid is heated, it melts at a distinct temperature. So a crystalline solid, the patterns they create, the patterns create crystals, and so those particles have to be in a regular repeating pattern. So let's head back to our notes. Types of solids. And our first type is crystalline. In crystalline solids, particles are in a regular repeating pattern. So what we mean by the particles in a crystalline solid being in a regular repeating pattern, here's table salt, which is an example of a crystalline solid, and you can see, do you see how it's very orderly, and they're in that 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. They're in nice rows, they're very organized. And then here, this is quartz crystal. And so this is kind of similar to fluorite. It's another mineral it's like fluorite was in your book. You can see how it makes these hexagons, and the particles are definitely in a repeat. So now let's take a look at the other type of solid. So if we go back to our text, the other type of solid that we have is an amorphous solid. In amorphous solids, the particles are not arranged in a regular pattern. Unlike a crystalline solid, an amorphous solid does not melt at a distinct temperature. Instead, it may become softer and softer or change into other substances. Glass is an example of an amorphous solid. A glass blower can bend and shape glass that has been heated. Plastics and rubber are other examples of amorphous solids. You can look at butter. Butter is a very good example of an amorphous solid as well. And so when we look at, let's add our notes, we can add amorphous. I'm going to have to look how to spell that one. Amorphous. And the particles are not arranged in a regular pattern. And let's give examples of each of these too. So an example of a crystalline would be snow, salt, sugar, quartz, crystal. An example of amorphous would be butter, plastic, rubber, and glass. So let's go ahead and take a look then at the pictures of what it means to have an amorphous solid. So that was what crystalline was. See how they were in a nice pattern. Now look at amorphous. So like cotton candy is an amorphous solid. Do you see how they're just all kind of all over the place? Glass was another amorphous solid. You can see how there's no pattern to it. Remember how we saw the hexagon with the quartz crystal? There's no hexagons here. They just look like blobs. So that's the difference between an amorphous and a crystalline solid. And that finishes up our notes on solids. The most important things that you want to be taking away from these notes, we're talking about the shape and the volume of each of the states of matter, and then you also really want to make sure that you know the arrangement of the particles. So from this point on, you can go back to your to-do list, and you can either fill out a portion of your graphic organizer on solids, you can make your solid concept card, and your amorphous and crystalline concept card, or you can choose to move on and just continue taking your liquid and gas notes.